Alright guys, so we're going to work on this lecture 5.2, verifying trigonometric identities. It's all about verification of an identity, and basically it is when someone gives you an answer and you have to show that the answer is true. So you will use identities to verify other identities. I'll let you read all the identities you are going to work with, and let's jump right away with the first example. So you have to verify that x squared plus bx plus c equal to a times x minus b over 2a squared plus 4ac minus b squared over 4a. So let's work on that. So first, there is a tiny mistake. It should be a plus right here. So I'm going to change that into a plus. And then, so we have to show that the left side or the right side of your equation is equal to the left side. So what I want to do is I'm going to take the a times x plus b over 2a squared plus 4ac minus b squared over 4a, and I'm going to simplify it. So first of all, that is equal to a times x squared plus 2x multiplied by b over 2a plus b squared over 4a squared. Remember, a plus b squared, it's a squared plus 2ab plus b squared. In that case, or should I, instead to have ab, what should I have is capital A. Like this, you're not confused. Okay, squared equal a squared plus 2ab plus b squared. Okay, plus 4ac over 4a minus b squared over 4a. So now what I'm going to do is distribute my a, and that's going to be ax squared plus 2axb over 2a plus b squared a over 4a squared plus 4ac over 4a minus b squared over 4a. I can simplify the 2a right here. I can simplify the a right there. 4a can be simplified, so I end up to have ax squared plus bx plus b squared minus b squared over 4a minus b squared over 4a plus c, b squared minus 4a minus b squared minus 4a, simplify, and so I end up to have ax squared, what I was looking for, ax squared plus bx plus c. So I verified that the right side of my equation was exactly the same thing than my left side. Alright, so let's try to verify the identity cotangent x sinus x sec of x equal 1. So very different strategy to do that. One of them is to try to simplify, and so what I want to do is express cotangent in terms of sine and cosine, express sec in terms of sine and cosine. So I end up to have my left side of the equation as a cosinus of the angle divided by the sinus of the angle, multiplied by the sinus of the angle x, multiplied by 1 over the cosinus of the angle x equal 1. I don't have the same denominator, but it's not a big deal because I have multiplication, okay? So what do we have? Basically, we have a cosinus x multiply by sinus x, multiply by 1, divided, and I multiply the denominator together, sinus x times cosinus x. And yes, it's equal to 1. So I'm very happy with that. I verified that the left side of my equation was equal to 1. That is one of the methodology that I like the most. Okay? All right. Let's try to work with the problem number 3 now. Let's try to verify the identity cotangent square of the angle theta times tangent square theta plus 1 equal cosec square of the angle theta. So the first thing I want to do is to express cotangent theta and distribute cotangent theta. So I'm going to have cotangent square of the angle theta multiplied by tangent square of the angle theta plus cotangent square of the angle theta. That is equal to what? So that is equal to cotangent theta equal 1 over tangent square theta multiplied by tangent square theta plus cotangent square theta. Then we have tangent square theta divide out. So 1 plus cotangent square of the angle theta. And what is it? Is it equal to what? Well, cotangent square theta, that is equal to 1. That is equal to 1 plus cosinus square of the angle divided by the sinus square of the angle. I don't have the same denominator, so I must multiply top and bottom by the LCD, the number 1. The LCD being sinus square, I need to multiply by sinus square of the angle and divide sinus square of the angle, the fraction 1 over 1, which give me 1. At the end of the day, I end up to have sinus square of the angle theta plus cosinus square of the angle theta equal sinus square of the angle theta. I know that sinus square of the angle plus cosinus square of the angle is supposed to be equal to 1. So this expression right here is going to be 1 over sinus square theta, because I know that cosec of the angle equal 1 over sinus of the angle theta. I can fairly say that 1 over sinus square is going to be equal to the square of your cosec. And yes, you proved that this part of the equation right here is equal to the other part of the equation. Okay? All right. I'll let you do the problem number 4 by yourself. It's going to take some time, but take it easy, and I guarantee you that if you are substituting tangent by sinus and cosinus, sec by 1 over cosinus, you try to do what you have to do, and you will see that you will find you will be able to give an answer if is it an identity or not. Remember also that you can always try to graph the left side of your equation and the right side of your equation, and if you have the same graph, it is an identity. But most of the time, they are going to ask you to prove it not by graphically, so take your time and try to do that, and you will be able to do it. I'm sure that. All right, I want to do the number 5 with you. Number 5, sec s plus tangent s over sinus s equal cosec of s divided by sec s minus tangent s. So let's try to do that. So you have an equation with denominator. The first thing you want to do is maybe get rid of the denominator. You are going to get rid of the denominator by multiplying the LCD both sides. And so you are going to, you know that the LCD is going to be sinus s multiplied by the sec of the angle s minus the tangent of the angle s. So if I multiply both sides by my LCD, I'm going to have sec of S minus tangent S, which is going to be multiplied by sec S plus tangent S. The sinus S will be divided out on the left side, and on the right side you have sinus S multiply cosec of S. Right away, you should remember that the cosec of an angle is equal to 1 over the sinus of this angle. Therefore, sinus S minus 1 over, no minus, what do I say minus? Multiply by 1 over sinus of the angle S is equal to 1. So if I'm able to prove that the left side of this equation right here is equal to 1, I will be able to prove that we have verified the identity. So what do I have right here? I got basically A minus B times A plus B. And I know it's supposed to be equal to A squared minus B squared. Therefore, it's going to be equal to sec of the angle S squared minus tangent square of the angle. What is sec? Well, sec is 1 over cosinus. So 1 over cosinus square of the angle S minus, and I'm going to express the tangent in terms of sine and cosine, sinus square of S divided by cosinus square of the angle S. I have the same denominator, so I get 1 minus sinus square of S divided by cosinus square of the angle S. I know, I'm going to write there that sinus square of the angle plus cosinus square of the angle is supposed to be equal to 1. So 1 minus the sinus square of the angle is supposed to be equal to cosinus square of the angle. Therefore, I'm getting a cosinus square of the angle S divided by cosinus square of the angle S, and that is equal to 1. So I verify my identity. Alright, finally in this last example, what do we have? First of all, I'm going to express the cotangent by being cosinus over sinus minus the cosec, which is 1 over sinus of the angle, divided by cosinus over sinus plus 1 over sinus, and that is supposed to be equal to 1 minus 2 cosinus theta plus cos squared theta. This right here looks like a square minus 2ab plus b square. So basically what we have is a 1 minus cosinus of the angle theta square divided by negative sinus square, and negative sinus square, it's negative 1 minus cosinus square of the angle theta, because I do remember that sinus square of the angle theta equal 1 minus cosinus square theta. Now, I'm going to continue what I have to do, flip my second fraction, because basically I have cosinus minus 1 over sinus of the angle theta divided by cosinus theta plus 1 over sinus theta, which is, if I just focus on this side, cosinus theta minus 1 over sinus theta, I convert the main fraction into a multiplication, and I'm ending to have sinus theta over cosinus theta plus 1. The sinus theta divide out, and I end up to have cosinus theta minus 1 over cosinus theta plus 1. So I just simplify as much as possible my left side right here. Let's focus on the right side. When I focus on the right side, I can definitely see that 1 minus cos theta square, the top, it's basically 1 minus cos theta multiplied by 1 minus cos theta. And on the bottom, I have a square minus b square, which is a minus b times a plus b. And when I divide out 1 minus cos theta top and bottom, I end up to have now this. The fact the minus is on the bottom will be the same if it is on the top now. And so I distribute the negative, and now both sides of my equation, the red one and the purple one, are the same.